Hey everyone, welcome back to another SAT math video. This is from the official test bundle number 6 from the year 2024. Which of the following is a solution to the given equation? And we have here w squared plus 12w minus 40 is equal to 0. Well, the first thing you should notice is we have a w squared term and then a w term. So what type of equation is this? This would be a quadratic equation, right? And you always can tell it's a quadratic equation whenever the first term that has a variable has a squared in it, and then it's followed by a second term with the variable that does not have a squared. So that's one thing we had to figure out first here. So when you try and factor out, when you try to find the solution of a quadratic equation, you usually have to factor it such that it comes into some form w plus some number times w plus like another number, right? So let's try and do that for this one and see if we can get one of these answers, right? So how do we factor an equation like this? Well, find the C term, right? That's our C term. Our C term is 40, and what we have to do is find two numbers that when multiplied together equal the C term and add up to the B term, right? They have to add up to 12, right? So again, we need two numbers that when times together equal minus 40, and then when added together equal plus 12. So let's see if we have any pairs of numbers that do that. Well, we could have like 4 times minus 4 times 10. That wouldn't really work because minus 4 plus 10, that would be equal to 6, right? So that doesn't work. Let's try another one. Maybe 20 minus 2 times 20. No, that doesn't really work either. What about minus 5 times 8? Still doesn't work, right? So we are in like the unique scenario where we don't really have any factors of 40 or negative 40 that add up to 12. When you are in a situation like this, you then will need to remember probably one of the most infamous formulas in math, the quadratic equation, right? And the quadratic equation is nothing more than x, or in this case, we can write w, but in this case, we can substitute w for x. It doesn't really matter, right? But x or w, I'm just going to write it in terms of x because that's what it's more commonly written as. So we have x is equal to minus b plus or minus the square root of 4ac all over 2a, right? So now you might be wondering, where did all these other variables come from? Well, recall that in a quadratic formula, you have coefficients, right? Coefficients meaning the numbers that are attached to variables, and then some constant term, right? So our coefficient a would always be in the first term right here, B is always in the second term, and then C is the constant in the third term, right? So you can kind of, pretty easy to remember, just remember A, B, C, and then it's the first three terms in that exact order, right? So now that we know what A, B, and C are, we can plug this in to the quadratic formula and solve for x, and remember that x is the same as w here, right? So let's plug everything in. So x is going to be equal to minus b. What is b? Minus 12, right? So minus 12. And then we're going to have plus or minus the square root of 4ac. So 4, we keep the 4 constant, right? What is the a? A is, well, if there's no coefficient explicitly written out, then we know that it's just a 1, right? So we have 1w right there, and then c is minus 40, so let's put that in there, minus 40, right? And then it's all going to be over 2a. So 2a, remember a is 1, so we're just going to have 2. Okay, so let's try and simplify that a little bit more. So then we're going to have x minus 12 divided by 2. That is going to be minus 6. And then we're going to have plus or minus this term, right? We're going to have 4 times 1 is 4. So then 4 times minus 40 is going to be minus 160, right? So we have minus 160 over 2, right? So now we just need to simplify this radical. Now, if you recall, you can't have a negative number underneath a radical, right? So this method probably does not work. So we're going to have to find a different way to solve this. So looking at this equation, right, we have a w squared plus 12w minus 40. This could be also solved using the completing of a square method, right? So let me just give some background on this method. Suppose I had like basically some like binomial term, right? Uh, if I were to square like x plus 2 squared, I would know that I would get like an x squared term. My middle term would simply be 2 squared, which would be 2 plus 2 rather, which would be 4x, and then my final term would be 2 squared, right? I mean, that's maybe not a best good example. Let's show you x plus 3 squared, right? So if I show you x plus 3 squared, then we will have an x squared, right? Because like I'm just basically expanding this, right? So let me write that out maybe in case that's not entirely clear. So if I have like an x squared, x plus 3 squared, which is nothing more than x plus 3 times the quantity x plus 3, we would do like, the multiplication that way where we distribute. So then we'd have x squared, and then we'd have this times that would be plus 3x, right? We would have a 3x here plus another 3x because then we do the inner term and then we do the outer, right? Plus 9. Or in other words, this becomes x squared plus 6x plus 9, right? So this is like a special property of positive binomials where when you square a binomial term, right? Binomial term is just some x variable plus another variable. When you square them, they always will follow this pattern where you have, so like say we have x plus a squared, right? It's going to be always x squared plus 2ax. So whatever a is, you just multiply it by 2, and then plus a squared, right? So that's kind of like our rule for binomial terms. And when you square them, you always, the middle number is just going to be the a term times 2, and then the final third term is going to be a squared, right? That's kind of what we see here, right? With 3. 3 times 2 is 6. 3 squared is 9. So we can leverage this property to try and solve this equation a different way, right? So let's try and run it over here. So we have w squared plus 12w minus 40 is equal to 0. So what plus what, or like what times 2 is equal to 12? 6, right? So maybe we can somehow utilize a w plus 6. Maybe we can try and make that appear in this equation. So how are we going to do that? Well, first we're going to plus both sides by 40, right? So I'm going to cancel that out. So then we get w squared plus 12w is equal to 40, right? So now what do we have to do? Well, we need to basically figure out what times what is going to be, or what is the number that we need to add to this side of the equation and this side of the equation such that this square becomes completed. Well, if we know 2 times 6 is 12, then we would need to add a 6 squared here, right? So we would just add plus 6 squared here and then plus 6 squared here, right? So then we get w squared plus 12w is 12w plus 36, right? Because 6 squared is 36, is equal to 40 plus 6 squared, or 40 plus 36, which would be 76, right? And now we can factor this, right? Because we know that this is going to be nothing more than w plus 6 all squared is equal to 76, right? And now we can kind of get rid of the squared term, right? By basically square rooting both sides, right? So square root in this side, and then I square root this side. That cancels out the square root. So we are left with w plus 6 is equal to plus or minus the square root of 76, right? So I think we can ignore the minus case for this one for now. I'll just leave it just in case. And what do we got to do now here? We need to then isolate w, right? So then w, to isolate w, we just subtract both sides by -6. So then w is equal to -6 plus or minus the square root of 76, right? And the reason I'm adding the plus or minus here is because you can always, like, you can multiply two negative numbers together to get whatever is in the square root, or two positive numbers, right? For example, like if I had the square root of 4, find the square root of 4 to get to square, that's going to be either 2, right? 2 or -2, right? Because 2 times 2 is going to equal 4, and then also -2 times -2 is equal to 4. So sometimes you'll see out in the radicals, or in front of radicals, this plus or minus, but it's just to account for the fact that some numbers can be, the square root of numbers can be achieved by negative numbers as well as positive numbers. So that's just to account for that. In any case, we need to now simplify this square root of 76. So to do that, I'd like to make little factor trees, right? So let's make a factor tree for 76. So this is going to be 2 times some number. Let's see, 2 times 2 goes into 7 3 times. So 38, right? Does that sound good? Yeah, that looks about right. And then let's break it down even further. So then 2 times what? 2 times maybe 19, right? 2 goes into 3 one time, and then you're left with 18, yeah? So there we go. That is what we have. So w is actually going to be equal to -6 plus or minus the square root of 2 times 19. Okay, so then we can take this term out, because whenever in the square root, if you have two of the same number, you can take that out and put it in front. So then w is going to be equal to -6 plus or minus 2 times square root 19. Okay, so let's see, do we have any term that looks like that? I believe our d term, right? Because this is plus or minus, so it can be plus 2 root 19 or minus 2 root 19. So it looks like d is our term, right? So there you have it. This one was not super straightforward, right? But so long as you remember this property, right? The property of completing the square, right? Where you have any binomial, you can complete the square by ensuring that you make the binomial follow this pattern. Then you are going to be able to solve this question. So I'm glad I actually left in the part where I tried to solve it this way, because in the SAT, you might find yourself doing the same thing. So, if you at first don't get an answer, you should always just reevaluate your methodology and see if there's a different way you can do it. So yeah, remember the term for this one is completing the squares, right? So that's kind of like the concept we use, completing the square, right? And that is in relation to binomial equations, right? So that's it for this video. Let me know in the comments if there is anything more I can do to make these better or more clear. Check out Khan Academy, of course. They are the best free resource to learn anything, including SAT and ACT. And of course, thank you so much for watching. I'll see you in the next one.